everyone, this is Kalpana here. In this video, we are going to solve a differential equation. So let's get started. Problem. Solve e power x sin y into dx plus e power x cos y into dy equals to y sin xy dx plus x sin xy dy. Solution. Given differential equation, e power x sin y into dx plus e power x cos y into dy equals to y sin xy into dx plus x sin xy into dy. So we are going to write all the terms containing differential dx on one side and all the terms containing differential dy on the other side. Okay, then we'll write dx, terms containing dx on left side, okay, firstly, and we'll take the term containing dy to RHS, then e power x sin y dx, this becomes minus, right? Minus of y sin xy into dx equals to x sin xy to dy minus e power x cos y dy. Okay, this is equals to, now take dx common from these two terms. You can write the above as e power x sin y minus y sin xy into dx equals to x sin xy minus e power x cos y into dy. Okay, now you can take this to LHS. Then e power x sin y minus y sin xy into dx minus of x sin xy minus e power x cos y into dy equals to 0. Okay, in the next step you can multiply these two terms with minus. Then e power x sin y minus y sin xy into dx plus minus x sin xy minus into minus plus e power x cos y into dy equals to 0. Then firstly we will write the term containing positive sign and next we will write the term which is containing negative sign. Okay, e power x sin y minus y sin xy to dx plus e power x cos y minus x sin xy into dy equals to 0, which is of Mdx plus Ndy equals to 0 form. Right. So now by comparing these two, we'll get m equals to e power x sin y minus y sin xy and n equals to e power x cos y minus x sin xy. Okay, if partial derivative of m with respect to y is equals to partial derivative of n with respect to x, we can say that this equation is an exact equation, or the given equation is called exact equation. Okay, So we'll find partial derivatives of m and n with respect to y and x. That is partial derivative of m with respect to y and partial derivative of n with respect to x. Okay. We have m equals to e power x sine y minus y sine xy, and n equals to e power x cos y minus x sine xy. Dou m by dou y equals to partial derivative of m with respect to y, e power x sine y minus y sine xy. Since we are doing partial derivative with respect to y, so x is treated as constant. Then e power x will be constant here, x will be constant. This equals to dou by dou y of e power x sine y minus dou by dou y of y sine xy. This equals to, you can write this constant separately from the derivative. Okay. Minus, here you're having y sine xy. So you can take it as some u, y as u and sine xy as v. We know that u v whole dash equals to u dash v plus v dash u, right? Then you can write this as v dash, that is dou by dou y of y, sorry, u dash into v plus v dash dou by dou y of sine xy into u y is equals to e power x into derivative of sine y is cos y minus of, you can write this as dou y by dou y into sine xy plus constant into derivative of sine xy is cos xy into inner derivative dou by dou y of xy. Okay. Is equals to e power x cos y minus of derivative of y with respect to y is 1 into sine xy plus y times cos xy into, here x is constant, right? So separate it from the derivative. You can write this as x into dou by dou y of y. Okay, this is equals to e power x cos y minus 1 into sine xy is sine xy plus y times x cos xy into, you can write dou by dou y of y as dou y by dou y. This is equals to e power x cos y minus of sine xy plus xy, y into x, xy cos xy into derivative of y with respect to y is 1. This is equals to e power x cos y minus sine xy minus into plus minus xy cos xy into 1 is cos xy. So dou m by dou y is e power x cos y minus sin xy minus xy cos xy. Okay, therefore partial derivative of m with respect to y is e power x cos y minus sin xy minus xy cos xy. Okay, now we'll find the partial derivative of n with respect to x. Partial derivative of n with respect to x. Dou by dou x of n e power x cos y minus x sin xy is equals to, since we are doing partial derivative with respect to x, so y is considered as constant. Okay, so here cos y will be a constant, right? So you can write that as dou by dou x of e power x cos y minus dou by dou x of x sin xy is equals to, since cos y is constant, you can separate it from the derivative. Cos y into dou y, dou x of e power x minus, here let u equals to x and v equals to sin xy. We know that here y is constant again. Okay, we know that u v whole dash equals to u dash v plus v dash u. Then you can write the above as u dash, that is dou by dou x of x into v plus v dash, derivative of, that is dou by dou x of sin xy into u, that is x. Is equals to cos y into derivative of e power x with respect to x is e power x minus of, you can write dou by dou x of x as dou x by dou x, derivative of x with respect to x is 1, okay, sin xy plus derivative of sin xy is cos xy, okay, into dou by dou x of inner derivative, okay, dou by dou x of inner function, I can say xy into this x is equals to e power x cos y minus of derivative of x with respect to x is 1 into sin xy plus x cos xy into, here y is treated as constant, so we can write this as y into dou by dou x of x is equals to e power x cos y minus of 1 into sin xy is sin xy plus x into y xy cos xy into dou by dou x of x can be written as dou x by dou x, that is derivative of x with respect to x. Okay, here also you can write 1 simply, or you can write in the next step, this equals to e power x cos y minus of sin xy plus xy cos xy into derivative of x with respect to x is 1 This is equals to e power x cos y minus sin xy minus into plus minus xy cos xy into 1 is cos xy. Okay, therefore dou m by dou x equals to e power cos xy minus sin xy minus xy cos xy. So from this too we can say that dou m by dou y equals to dou n by dou x. Therefore dou m by dou y equals to dou n by dou x. Since dou m by dou y equals to dou n by dou x, from this we can say that the given equation is an exact equation. Okay, or the reduced form of the given equation. Consider that equation as 1. So therefore 1 is an exact equation. Okay, fine. So the general solution of exact equation or given exact equation is integral over x m dx plus integral of terms of n free from x into dy equals to 0. Not 0, constant. Sorry. Okay. So now firstly we'll find integral over x m into dx. Integral over x m into dx equals to integral of, see here we are integrating m with respect to x, treating y as constant. Okay, so we have m equals to e power x sine y minus y sine xy into dx, right? Since y is constant, so we can treat sine y as constant and here y as constant. Okay, is equals to integral e power x sine y dx minus integral y sine xy into dx. So this is equals to, let's write the constant outside the integral, then you can write this as sine y into integral e power x dx minus, since y is constant, so take it outside the integral. You can write this as y integral sine xy into dx. Okay, we know that integral e power x dx is e power x, so this is equals to sine y into e power x minus y into integral sine xy is minus cos xy by y, since y is constant, right? So here y gets cancelled. This is equals to e power x sine y minus into minus plus cos xy. Since integral e power x dx equals to e power x and integral sine ax dx equals to minus cos ax by a. Okay. So therefore integral over x m into dx is e power x sine y plus cos xy. Now we'll find the second integral. Integral of terms of n free from x into dy is equals to, now we have to find the terms of n which is free from x. So this is n, right? We don't have any term which is free from x. See, here we are having e power x, so we can't take this, and here also we are having x into sine xy. So there is no such term which is free from x in n. So take it as 0. Integral 0 dy equals to 0. So therefore, the general solution of the given equation of 1 is integral Mdx. Integral Mdx is e power x sine y plus cos xy plus integral of terms of n free from x is 0 equals to constant c. Then e power x sine y plus cos xy equals to c is the required general solution. Okay. So we have seen a problem from exact equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.